Hey everybody, my name is Raghav Kalyanaraman, and today I just want to go over a few things about the Soil Erosion Prevention Project at LLELA. We did this project on the Blackjack Trail, which is a 1.3-mile long trail that is the most walked, most famous trail of the park. Unfortunately, this trail has two major problems after rainstorms due to its slopey terrain. First of all, runoff water gains momentum and causes soil erosion as it flows down the trail at higher speeds. Second, when sections of the trail get muddy, the visitors tend to go around them, which results in a thing known as trail widening, which is a process by which trails get wider than they should be. The trail cannot be rerouted around the areas where water picks up speed, and therefore we must come up with a more permanent solution that'll work for the longer term. But before we get into the solution, let's talk about exactly what soil erosion is. Soil erosion is a specific type of erosion in which the topsoil and nutrient-rich soil is blown away by wind or carried away by water. Erosion of soil requires a few things to happen. Soil detachment, which is the uprooting and loosening of the soil from the ground. Movement, which is the wind, water, or natural agents that disperse the soil away from the origin. And deposition, where the soil is deposited in many places, sometimes far from the origin. And this brings issues to the origin, which we'll talk about in a moment, as we'll see how important the Blackline Prairie soil truly is to the ecosystem. Common signs of soil erosion include exposed tree roots, cracks in soil near a riverbank, which there is a riverbank in the that goes along the Blackjack Trail, small channels and gullies that are formed as a result of the runoff water, and dips in the middle of the trail are all problems the that are all common signs of soil erosion. The importance of the blackland soil is highlighted with a few things. First of all, there is less than 1% of the blackland prairie remaining today, and the blackland prairie soil is critical for the thriving of native grasslands that are grown on blackland prairie soil, and these grasslands protect the watershed and increase water infiltration. Without them, water infiltration is significantly reduced and causes less water yield per year, which will affect us directly. Soil properties is quite interesting when talking about Blackland Prairie soil. We'll go into the Atterberg limit, and in this situation, the liquid limit, which will show us how vulnerable our Blackland Prairie soil really is to erosion by water. Liquid limit is the minimum amount of water required to bring soil to a viscous liquid state. Viscous liquid state is like glue type state, not fully solid but not fully liquid. In a geoscientist study, artificial rain tested proved that alkaline soils have a lower LL or liquid limit percentage than acidic soils. Because the Blackland Prairie soil is very fine and therefore very alkaline, the lower liquid limit means makes it more likely to be carried away by water. And because our Blackland Prairie soil has that lower liquid limit, it is much easier to erode by water, and thus showing how important that this problem is to our soil. At the moment, the current workaround solution are the Puncheons, which LLELA uses right now. These are structures placed along the trail which allow visitors to get across the muddy areas to prevent the trail widening that we talked about before. These are movable and easier to construct, and they can be placed wherever required, especially when there is a day when a lot of visitors are planning to show up. However, the problem with this is that these only prevent trail widening, but they do not address the soil erosion problem. And this is what we have been doing by installing what are called water bars. Water bars are timbers placed along the trail at angles to divert and or reduce the velocity of runoff water, thus reducing erosion. Water bars only have to be a few inches above the ground and following a 30-degree angle, and they should be sturdy enough to withstand the fast-moving water. Take a look at the image on the left, showing a piece of timber on the trail, which is used as the downhill slope of the trail will allow the water to hit the water bar, but instead of continuing down the trail, it will instead go to the ditch to the side where the water will be at more of a standstill. And standstill water is better than moving water. Water bars do take advantage of these trail slopes to redirect water, and each water bar is decided case by case. And this is because each installation has different terrain and different sloping directions, and because the Blackjack Trail has such a variety of them, it is important to take that into consideration before installing these water bars. For the building material that we used, we got the 8-foot landscape timbers from Lowe's. These were pressure treated wood able to resist severe weather and rot, and the wood that we have can last for up to 10 to 15 years depending on how the weather is. And these were occasionally cut due to the situation of the trail, and this happens because there are times when the trail is narrower or we need to install what are called stair steps um, in order to bring a more in order to reduce the velocity of the water instead of really diverting it. The smaller sized water bars are better for that. For securing the water bar, we used rebar stakes, and these are 1/2 inch by 18 inches long. And these dimensions work really well as the rebar can firmly grip the dirt and the wood really well. The rebar is to be hammered into the sides of the timber placed, and dirt packed around the timber should also be done in order to further secure the water bar in the ground. We did what was called the kick test to make sure that our securing was completed and successful. And we did this by simply kicking the water bar to see if it would move or shake based off the strength of our kick. And if the water bar did not move, then that means our securing was done well. The sustained vision for this trail is as shown. As less water stays on the trail, sediments will begin to cover up the dips and damaged areas of the trail over time. And this will allow the trail to become smoother and be less prone to water erosion in the future. Periodic inspections will be needed to secure any loose ends of the anchors or to clear any debris that gets caught on the water bars. What can you do to help? First of all, there's always joining the efforts by helping in both volunteering to install and repair water bars, and most importantly, following the trail and only the trail. This is important as we want to prevent that trail widening, which, while the water bars help soil erosion, we have to really help people understand the true problem that these trails are facing. And also, lastly, watch your step if you come across any water bars, as we don't want to kick them out of place or move them over time. And with that, I really want to thank you guys for your time and listening out to this presentation. I hope you guys, next time when you come across a trail and you see a water bar, you too can explain to your friends or family what that really is and how it is helping the trail and the ecosystem and environment as a whole in the future. Thank you for your time.